In this video, we're going to determine whether or not a graph is a graph of a function. And we're going to use a test called the vertical line test, where we look to see if every vertical line crosses the graph of the relation only once, at most once. If so, it's a function. If the same x value has two different y values, like we have on this relation right here, it's not a function. So let's determine whether the graph is that of a function by using the vertical line test. In either case, use the graph to find the domain and range, the intercepts of any, and any symmetry with respect to the x-axis, y-axis, or origin. So is the graph a function? No. The graph is not a function because the vertical line x equals 2 intersects the graph at 2 points. So that's A. The domain is going to be negative infinity to positive infinity because both of those pieces there go all the way to the left and all the way to the right. They have implied arrows at the end of them. Since I don't see dots at the end to show that they're closed, assume that there's arrows there. The range goes from negative infinity up to and including -5. And then picks up again at +5 and goes to positive infinity. Those solid dots right there, those vertices are going to be included with brackets. Infinity is an idea, not a number, so it gets a parenthesis. We can approach it, but we can never get to it. Select the correct choice, and if necessary, fill in the answer box to complete your choice. The intercepts are, and they're at 0, 5 and 0, -5. And here you see that they tell us to answer as an ordered pair. So now we're saying that the intercepts are ordered pairs. What kind of symmetry do we have? So we definitely have y-axis symmetry here. And we definitely have x-axis symmetry here. And it looks like we have origin symmetry here as well. So A, B, and C, we have all types of symmetry because this piece folds over the origin to make this piece folds over the origin to make this piece, and vice versa. This piece reflects over the x-axis to make this piece reflects over the y-axis to make this piece, so on and so forth, that we have all three types of symmetry going on in that graph. Now let's determine whether the graph is that of a function by using the vertical line test, and in either case, use the graph to find the domain and range, the intercepts if any, and any symmetry with respect to the x-axis, y-axis, or origin. Yeah, that graph is a function. So because every vertical line intersects the graph at most 1 point, so that's B. The domain here of this function goes from -π included to π included, and the range goes from -1 included to 1 included. We'll talk more about what this type of graph looks like in the second part of pre-calculus. So, and what all those funny pi things have to do with it. But right now, the intercepts are at -π/2, 0, π/2, 0, and 0, 1. Both x-intercepts and a y-intercept there. It's symmetric to the y-axis. It's not symmetric to the x-axis. And it's not symmetric to the origin. It's just symmetric to the y-axis. Let's keep going here. This is not a function because it doesn't pass the vertical line test. The vertical line x equals -4 intersects the graph at 2 points. So that's A. Its domain is going to be -infinity to -2 included. Its range is going to be -infinity to positive infinity. and it only has a x-intercept at -2, 0, no other intercepts, and it's symmetric with respect to the x-axis, and it has no other kind of symmetry. Let's go ahead and look at number 4 now. Is this a function? It most certainly is. And they're showing asymptotic behavior here with that arrow, saying that it's going to get close to an approach, but not ever get to x equals 0 there. So yes, the graph is a function because every vertical line intersects the graph at most at one point. The domain is going to go from 0 to 6, sorry, to 5, and 5 is not included because there's an open circle there, and the range is going to go from -infinity to, and that's a 3, and that's not included since there's an open circle there, a hole, and there's an intercept there on the x-axis that is at 1, 0. Probably have to zoom in a little closer to see that pretty well, but that's halfway between there. It's actually right on that first tick mark right there. So each tick mark is 1, and it's on the first tick mark right there. And there's no symmetry for this graph. It's not symmetric to the x-axis, y-axis, or origin here. So now let's look at this relation. Is that a function? It certainly is, because every vertical line intersects the graph at most at one point. So that is A. Its domain, it goes all the way to the left and all the way to the right. So that's -infinity to infinity. Its range goes from -infinity, because it goes all the way down, up to and including +3. It's bounded at the top. Its intercepts are -2, 0, 2, 0, and 0, 3. And oh, sorry, this is not 2. Look again at these tick marks, 1, 2, 3, 4, 5 to get to 15. So each of these is 3, so that's actually a -6. And that's a +6. And there you go. Don't get fooled by those tick marks. Watch out, they're not always 1s. It is symmetric about the y-axis, and it's not symmetric about the x-axis, and it's not symmetric about the origin. One more question here. Lots of tiny tick marks here. So this relation here is a function. So its domain is -infinity to infinity, and its range goes from -9, is that y value down there, to +infinity, and it has intercepts at -1, 0, and -7, 0. So -7, 0, -1, 0, and 0, 7. Okay. It's not symmetric about the x-axis, y-axis, or origin because of the translation that's happened. It's been shifted left and down from its original parent graph. We'll talk more about that in future sections. So that's it for this video. We'll come back next time and keep talking more about 1.2. See you for the next video.